Okay, question 4. So we need to explain the operation of a step-down transformer. So the first thing to say is that the voltage in the primary coil is going to be greater than the voltage in the secondary coils. Okay, and that's important because, that's telling us what a step-down transformer does. It reduces the voltage. The second thing that we can get from the diagram is this bit here, okay, which is an important concept, okay, that the current in the primary coil, or the voltage in the primary coil, is changing. Okay, you can call it an alternating current. You can say it's got a frequency of 50 hertz, which is the frequency of mains electricity. Any of those, but just this idea that we've got a changing current in the primary coil. And because of this changing current in the primary coil, that is going to give us a magnetic field in the core. Okay, and the symbol that we tend to use for magnetic fields is B. Okay, and it's actually a changing magnetic field. Okay, because the current is alternating 50 times a second, this magnetic field will change 50 times a second. Now notice the language that I used there. I didn't use the word induced. Okay, induced is a very special word that means a changing magnetic field producing a voltage in a coil. But this is the opposite. This is a coil producing a magnetic field in a core. All right? So we can't use the word induced for that. You can use the word causes. So you can say the AC current in the primary coil causes an alternating an alternating magnetic field in the core, or a changing magnetic field in the core. Now, the reason that we use an iron core is that actually strengthens the linkage between these two coils. Okay, so it creates a stronger field between these two coils, and that's another way that you could have accessed one of these 4 marks. And now the secondary coil experiences a changing magnetic field, okay, through the core, and then that, of course, now we can use that word, the changing magnetic field in the secondary coil induces a voltage in the secondary coil, and of course it induces an alternating voltage or an alternating current in the secondary coil. Okay, so lots, I think there's 7 different ways that you could score those 4 marks there. So you didn't have to get all of those, but you did have to get 4 of those points that I just mentioned. And then final question, calculation question. This should be pretty straightforward for us, hopefully. Okay, we can look here and we can grab the formula from there. Okay, what was it again? They're using input, the primary voltage. Okay, so the voltage of the primary over the voltage of the secondary is equal to the number of turns on the primary. It's conventional to use a lowercase n. Okay, that's not obvious. They didn't use the symbols on their sheet, but you're okay to use the recognised symbols. Okay, and then what have we got? 160 and 45. So 160 over 45. Okay, and then you've got 12 here. And Vs there, and you just do a bit of cross multiplication, okay, and that should get you a voltage in the secondary coil of 3.4 volts. Great, and that's the end of paper 2.